This video is on solid revolution, and I have this yellow region right here, and I'm going to revolve it about the y-axis, and I want to find the volume of the solid revolution. And so here's the yellow region. It's bounded above by the line y equal to 5, and then this curve here is the curve y equal to 0.2x minus 1 squared. And this is the line x equal to 1. And the axis of revolution is the y-axis. So we're going to revolve this yellow region right here around the y, about the y-axis. And this is what the solid of revolution looks like. So here's the yellow region again. So when we revolve it, then we get a hole or a cylinder right in the middle. And then around it we get the bowl. So to get the volume of this solid of revolution, what we can do is find the solid without the hole, and then subtract from that the volume of the cylinder in the middle here. And so here's the solid without the hole. So we're gonna find the volume of this bowl or this solid of revolution here. And just like before, to find the volume of this solid of revolution, we're gonna slice this bowl right here, slice it horizontally into many slices, and then find the volume of each slice. And here's one slice. And so let's call this the ith slice. So let's go find the volume of this ith slice and then find the volume of the solid without the hole. And so first we need to find this point right here so that we know what the range for y is. And so we know that this line here is y equal to 5, and then the curve here is y equal to 0.2x minus 1 squared. And so at this point right here, y is 5, and so in the place of y we have 5, and then divide or multiply both sides by 5. We get x minus 1 squared equal to 25, and then take the square root of both sides. We get x both sides. We get x minus 1 equal to 5, or x equal to 6. And so at this point right here, x is 6, y is 5. And so this bowl here, it ranges, the y values ranges from 0 at the origin right here up to 5. Since the axis of revolution is the y-axis, then we need to solve this equation here for x. And so multiply both sides by 5, then we get x minus 1 squared equal to 5y. And then take the square root of both sides. We get x minus 1 equal to the square root of 5y. And so x is equal to the square root of 5y plus 1. And so let's call this equation right here, let's call it this, let's rewrite it as f of y equal to the square root of 5y plus 1. And now let's find the volume of this ith disk right here. And so this ith disk, it comes from this ith interval right here. And so the value right here would be y sub I minus 1, and then right here would be y sub I. And so right here on the y-axis, at the center of the disk, and so the disk right here would intersect the y-axis at y sub I. So the distance from the y-axis out to the graph would be f of y sub I. And so notice that the f of y sub I is also the radius of this disk in this case. And therefore the volume of this ith disk is going to be pi times the radius squared times the height. And so the radius is the square root of 5 y sub I. and plus 1. And then the height of this disk, ith disk, or the thickness of the disk, we call it delta y. And so this is the volume of this ith disk. And if we divide this solid of revolution right here into n slices or n disks, then the volumes of n disks would look like this. This will be volume of slice number 1, volume of slice number 2, and then volume of the nth slice. And using what's called summation notation, then we would have I running from 1 to n, and then with the expression pi times the square root of 5y sub I plus 1 squared, and then times delta y. And once again, delta y, this is the thickness of the ith disk, and the square root of 5y sub I plus 1 is the radius of the disk. And then simplify here, we get 5y sub I, and then 2 times the square root of 5 times the square root of y sub I, and plus 1. So this is volumes of n slices. And so the volume of this solid right here without the hole is approximately this sum. And once again, if we want the exact volume of this solid without the hole, then we need to divide this solid into an infinite number of slices, meaning allow n to approach infinity. And then we would write it as the limit of the sum as n approaches infinity. And when this limit here exists, then we would redefine it as the definite integral from 0 to 5, 0 to 5. And then here we have the pi, and then here's 5y, and then 2 times the square root of 5 times the square root of y, plus 1 and dy. And then we just integrate. And so here's the pi, and then the integral for y is y squared over 2, and then the integral for the square root of y is the same as y to the 1/2. So the integral would be y to the 3/2 dividing by 3/2. And then integral for 1 is just y. And then this part right here becomes 4 times the square root of 5 over 3. And then we need to evaluate from 0 to 5. So when y is 5, we get 125 over 2. And then here, when y is 5, we get 5 to the 3/2, which is 5 square root of 5. And then here, when y is 5, we get 5. And then when y is 0, then we get 0 with the lower limit of integration. And then simplify everything, and we will get 605 over 6 times pi. So this is the volume of this solid of revolution right here without the hole. And so in summary, what we want is the volume of the solid with the hole. And so the hole is just a cylinder. So the volume of the cylinder is pi times the radius squared times the height. The radius of this cylinder is just 1. And then the height of the cylinder is 5. So the volume of the cylinder is 5 pi. So the volume of the solid with the hole is 605 over 6 times pi. And then subtract from that 5 pi, we get 575 over 6 times pi. So the volume of this solid with the hole is 575 over 6 times pi. And that's the end of the video.